Hello everyone. Through this video we are going to discuss question number 4, 5, 6 and 7 of exercise 1.2. So here goes exercise 1.2. This is exercise 1.2. This is question number 4. So in question number 4 what is given? The question is this: given that HCF of 306 and 657 is equal to 9. Find the LCM of 306 and 657. So this is the question. So in solution part, what do we have to write? Given HCF 306 657 is equal to 9. That means HCF is given to be 9. Given numbers are, the numbers are 306 and 657. To find LCM of 306 and 657. So this is the question here. We know one formula. We know that now in this case there is one formula. HCF into LCM is equal to product of the numbers. So in this case HCF is already given to us and the result is 9 here. Yes or no? And LCM is unknown to us. So product of the two numbers, in this place the given numbers are, what are the given numbers? The given numbers are 306 and 657. So here in this case what do I have to write? 306 into 657. So LCM will be what? We have to divide both the sides by 9 because we have to remove 9 from this side. So 306 into 657 divided by 9 it is. Let's divide 9. Cancellation will take place here. 9 3 ja 27, then 36, 9 4 ja 36. So LCM will be equal to, let's see what result we get, 657 into 34. The result will be 28. 2 left, it is 20. 5 4 ja 20 plus 2, 22. 2 is left again, 24. It will be 26. Then after by 3 I have to multiply. 2 left, then 17, again 1 left, then 18 plus 1 19. So let's see, this 3, then again 3, 1 left, it will be 2, then this is 2. So ultimately our answer will be 22338 and this is the required answer. So here goes question number 5. In question number 5 what is given? Check whether 6 to the power n can end with a digit 0 for any natural number n. So here in this case we must have to notice one thing, that the value of n should always be natural. Okay, I mean n should always be a natural number. Now 6 to the power n, if I do factorization of 6 first, I shall be getting 6 is equal to 2 into 3. Yes or no? Therefore 6 to the power n will be equal to 2 into 3 whole thing to the power n, that is equal to 2 to the power n into 3 to the power n. Now for any number ending with the digit 0, let us check what factors are must. Say first number is 10. If I do factorization, I shall be getting here the result to be 2 into 5. Yes or no? For 20 the result comes as 2 into 2 into 5. Similarly say for 60 it is So 60 when divided by 2, we are getting here the result to be 30. Then again divided by 2, I am getting here 15. Then after by 3, it is 5. So the results will come like 2 into 2 into 3 into 5. So in these all cases, we find that 2 and 5, these are the common factors. Yes or no? These are the common factors. 2 and 5. Then after here also 2, 5. Then there also 2 and 5. So here in this case, for all those numbers ending with the digit 0, while doing factorization, 2 and 5 should come as a common factor. Means always we should get 2 and 5 wherever there is a number ending with the digit 0. So this is the thing we have to keep in our mind. Now in this case, while doing factorization of 6, I got only 2 and not 5. Okay, in this case no 5 is there. Yes or no? So therefore, if there is no 5 is there, so it is very clear that this number is not going to end with the digit 0. If 6 does not end with the digit 0, how can 6 to the power n end with the digit 0? Yes or no? Suppose 5 is a number. Suppose 5 square. 5 square is 25. If 25 is not ending with the digit 0, how can 25 square end with the digit 0? No possibility. So that's the thing we have to keep in mind. So while writing the answer, how do we have to write? If the number 6 to the power n for any natural number, n is to end with the digit 0, is to end with the digit 0, then it must have 2 and 5 as its factors. But in 6 to the power n, there is only 2. There is only 2 as factor and not 5. Hence, it is clear that 6 to the power n cannot end with digit 0. So this is the answer. So coming to the next question. So here goes question number 6. So in the solution part, what is given actually in this question? Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So let us consider the first case here. Here 7 into 11 into 13 plus 13, that is equal to, we can take common 13 from both the sides. Yes or no? 13 is taken common. Within the bracket, what is left? 7 into 11 plus 1. Yes or no? Is equal to 13 into, in this case, 77 plus 1. The result comes as 13 into 78. Now, what is the definition of a composite number? What is a composite number actually? A composite number is what? Composite number is equal to product of primes. Now in this case, we are already getting 13 as a prime number. What will happen to this 78? We must have to do factorization on this part. Let's do factorization. So dividing this by 2, what do I get? 2 3 ja 6, then 18, 2 9 ja 18. So after this by 3 again I divide it, 3 13 ja 39. So after this, what do I get? What do I write here? 13 into 2 into 3 into 13. So these are what? Product of primes. Product of primes. Hence, it is a composite number. So for the next part, for the next question, it will be what? Again, what do I have to write? Again, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is equal to what? In both these two cases, what do I get? I get 5 and 5 as common factor. So in the next step, taking 5 common, within the bracket, what do I get? 7 into 6 into 4 into 3 into 2 into 1 plus 1. The result will be equal to 5 into, within the bracket, what is the calculation? We have to find that out. 6 into 7, the result will come as 42. That should be divided by 4 3 ja 12. Let us check what answer we get. It is 4, then after 8, then after 2 here, then 4. The answer comes as 4, then 10, 1 left, 504. Again, that has to be divided by 2. So we get here 8, 0, then after 10 here. That means result will be 1008 plus 1. That is equal to 5 into 1009 is equal to, again, product of primes can be expressed as product of primes. Hence, it is a composite number. So this is the answer of this question. Here goes question number 7. So in this question, what is said? Let us check. There is a circular path around a sports field. There is a circular path around the sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and same time and go in the same direction. After how many minutes will they meet at the same starting point? So the main question here will be what? What we have to calculate, in what way we can derive this result. How many minutes will they meet? After how many minutes will they meet at the same starting point? So actually, suppose this is the circular path. In this circular path, say this is the starting point. Both are traveling in the same direction with the same from the same starting point, say at the same time and in the same direction. So just there is a difference. One of them is having more actually one of them is taking more time and one is taking less time. So in this case, there must be something common, yes or no, which will allow them to meet at the same starting point again. That common thing, there is a minimum common time which will allow them to meet at the same starting point. So that is nothing but LCM. Okay, LCM of both 18 and 12 we have to calculate here. So coming to the solution part, here I shall write time taken. In the solution part, time taken by Sonia is equal to 18 minutes and time taken by Ravi is equal to 12 minutes. So after this, to find out the least time after which they will meet each other, That is what we have to calculate, LCM of 18 and 12. Now by prime factorization we are going to proceed here. what we need to write? By prime factorization. Here I shall write here 18 is equal to, it is known to us, it will be 2 into 3 into 3. The result is 2 into 2 into 3. So that means 2 3 ja 6, 6 3 ja 18. Again for 12, what can we write? We can write like 2 into 2 into 3. So LCM in what way can we take here? 18, 12 is equal to the common terms. These are the common terms, 2 and 2. And I find here 3 and 3 common. So common terms in both the cases we have to consider once. And the uncommon terms, all the uncommon terms we have to take along with the common terms. Okay. So let us check what result we get. The product will be 36 minutes. And that is the answer. So with this exercise gets over. Thank you.